Hello, everyone, and welcome back to the series, our session 3 today for the Marketing Cloud Architecture and Implementation Strategy series. Your host for today, myself, Shibu Ibrahim, and I have Natasha Galani here as well. We're the group leaders for the Toronto and the Malaysia Marketing Cloud Trailblazer community groups. Natasha, do you want to go ahead from your side, introduce, and then introduce the speaker as well?
Yeah, thanks, Shibu. Welcome, everyone. And as Shibu mentioned, this session was supposed to be last Tuesday, but we had technical difficulties. So following up today, I am the Toronto group leader, the Crow group leader, and I'm just going to get started. Today, we have with us Jason, who is a marketing cloud solution engineer. He's also a champion. Sorry, my slideshow keeps doing that. And he will talk about all things integrations. And as we all know, and those who have spent quite a bit of time with Marketing Cloud, integration is pretty much 50 to 70% of what we do. So with that said, I'll pass it over to Jason. Our next session after this will be by Greg, TBD on timing, but we'll get back to you soon. A couple of housekeeping items before I get started. All these sessions are recorded, and we will add the link to where you can find them in the chat very soon. And if you have any questions, feel free to put them on chat, and Jason will get to them as soon as he can. With that said, over to you, Jason.
Thank you so much. Let me share my screen. Okay, can you see?
See it perfectly.
Great. So today we're going to discuss integrations in Salesforce Marketing Cloud. As a caveat, this will be somewhat generic. So we'll discuss really Marketing Cloud as a cloud services in kind of a more comprehensive picture of web services generally, but also touch on some individual points of integration into Salesforce Marketing Cloud. So who am I? I'm Jason Hanshaw. I am the Director of Marketing Technology at FCB Health, co-author of a recent book with Greg Gifford, Automating Salesforce Marketing Cloud. And I have experience developing solutions, both external and within the platform for many years. So the agenda. First, we're going to take a look at an overview of what integration is, kind of get a definition and set the boundaries there. We'll examine the differences between custom and out-of-the-box integrations, sort of the pros and cons of both approaches and what both entail. We'll take a look at APIs, examine some different kinds of APIs, and just kind of get a lay of the land. We'll take a look at webhooks. What is a webhook? How it differs from an API. We'll take a look at what a design pattern is and just go through one sample design pattern to get an idea on how modern applications are structured. And then we'll just look at a few examples to kind of see how an integration might look, and then maybe take a look at that design pattern structure with a fleshed out example. After that, we'll do some final thoughts and then some Q&A to round it out. Okay. So what is an integration? An integration is simply a mechanism by which an application, service, or website can transmit and receive data from other sources using a common set of protocols. That's a technical definition, I guess, to really cover something that I think most of us already know or understand. It's really just a way of connecting disparate systems to transmit data, action on some event, and is really the cornerstone of not only the things that we do in Marketing Cloud, but a lot of the services and applications that we use today offer some integration of some kind or rely on it to provide the service that you enjoy. So let's take a look at some examples. Most of you will be familiar with these. So the most common one, Salesforce Marketing Cloud Connector, right? It's a pre-built integration that you can install as an application within Sales and Service Cloud, Health Cloud, that allows us to integrate that Salesforce data and action on it within Salesforce Marketing Cloud so that we're able to synchronize the data sources, key off journey entry events, and doesn't take a lot of thought to really see how powerful that can be. That allows us to do things that we aren't really capable of doing outside of the box or without building some complicated integration ourselves. Next is Datarama connectors. So if anyone's worked in Datarama, Getting data from all these disparate sources obviously can be a challenge, but they have pre-built integrations that allow us to use single sign-on with popular platforms, Google Ads, LinkedIn, YouTube, Google Analytics, sort of the whole gamut that allows us to easily stream that data directly into the platform through a pre-built integration. Another would be Query Studio, so a popular application in the Salesforce Marketing Cloud ecosystem with good reason. Allows us to automate a lot of those existing processes that are a bit cumbersome when we're creating queries, setting up the data extension and then creating query activity. Having a pre-built integration into Salesforce Marketing Cloud that allows us to automate those processes just makes things more efficient and it's easier on everyone else. Data transfer, probably the most common integration example within Salesforce Marketing Cloud. So, even a cloud page that upserts data to a data extension, right? That is a form of an integration to Marketing Cloud, even though it uses sort of that pre-built, AMP script functionality to do that. It is an integration, but also we might have external web applications or websites that use a service layer, right? It's a pretty common type. So the form submits, goes to a middleware application that's able to log the data, store it, in case anything goes wrong, maybe format it, change the data a little, sanitize it, and then pass that over to Salesforce Marketing Cloud. So, and obviously sending data to data warehouses, that's a data integration from Salesforce Marketing Cloud. So very common use case that's extremely important for most of the work that we do. And lastly, custom integrations. And so that can be a bit of, it's really all of those, right? All of those are custom integration to some degree, not for the end user, but more for the creator, I think, in this scenario. But a custom integration is really when we have some kind of data or event or anything that we want to transmit between two systems or services that doesn't already exist, right? We have to create that integration, set up the deployment process, CI/CD, everything to get that going. So custom integration is a big blanket term, but it's very important when pre-built options don't exist. So to that end, and we sort of touched on it there, there are really two ways of thinking about integrations in the web services arena. And we could think of them as a custom integration, which you just explained is one that doesn't already exist and one that you're creating to provide some capability that you currently don't possess. And the other is out of the box. So one that already exists, Datorama would be a good example, right? They already have those integrations prepared for you. So you don't have to create them yourselves. You don't have to handle everything related to the development and deployment and planning related to that. So both come with some advantages and disadvantages. First, let's take a look at out of the box. So, one of the most challenging aspects of deciding between these two, but also choosing an out of the box solution is even knowing the available options on the market, right? So you might have an extremely niche use case that would warrant a custom integration simply because there aren't any providers that provide that level of detail for an out of the box integration. Taking Datorama, for example, let's say I had a custom data application that's aggregating all this wonderful data from my organization, but it doesn't have, it's a custom sort of application that doesn't have some pre-built API or something that Datorama would have an automatic connector to simply because it's a custom app. For that, you're not going to find an out of the box solution. You're going to have to build some integration yourself simply because it's not a common tool. And to that end, for out of the box integrations, they will almost uniformly deal with extremely common use cases. So like LinkedIn, YouTube, Google Ads, or Datorama, right? Something that a lot of people use and that they would be able to provide a lot of utility to a common use case. But obviously, let's take a look at some advantages with that. I mean, when you're examining, we'll start with out of the box solutions. When you're examining out of the box solutions, it's pretty easy to discern the common advantages and disadvantages associated with using this solution. By the very nature of this solution, they are likely to be generalized, applicable to the widest possible use case or discipline, but will sacrifice some of those niche use cases. So the first big advantage of choosing an out of the box integration is cost. Looking at Salesforce Marketing Cloud Connector, looking at Datorama, or any of the examples we gave in the previous slide, it's simply cheaper to use an existing solution, even if there is some upfront cost to purchase the service or maybe have a monthly subscription fee. it saves a lot of money in resources, planning, QA, development, deployment. Those can add up quite quickly. So obviously choosing one where a lot of that has been planned out for you, it's already done, you know that it's a stable process, that obviously saves quite a bit of money compared to the alternative. The other would be project duration, right? Similar to the arguments around cost, but implementing your use case on an existing platform simply saves a considerable amount of time that you could have used on other projects. So there's an opportunity cost associated with that. The time you spend building out an integration that already exists somewhere else is time wasted that you could have spent improving some other process within your workflow. And lastly, quality and stability. I mean, it goes without saying, a large platform provider that has built an existing service, has thoroughly tested it. It's, gone through the rigors of production, bugs that have been patched and QA'd. They're providing the platform for, throughput and efficiency. So that when you're using an out-of-the-box solution, you're very likely getting a high-quality product if you're using a high-quality vendor. So you get existing support for API requests, not having to tackle those issues in-house obviously is a huge advantage. So the disadvantages, obviously flexibility. I mean, you are limited by the functionality that's provided. And we've touched on that if you have niche use cases, you're not going to find a lot of support or maybe no support with out-of-the-box solutions. So this is to that end, you don't have control over those functionalities provided by individual platforms. Next is hidden cost. So let's say you found a quality, well-respected service, accomplishes everything that you need for a project. But there might be additional hidden fees that come in with using this service that aren't necessarily viewed up front. Maybe they change the service plan that you're using. Maybe they charge more for the bandwidth that you were not anticipating paying for. So sometimes you can get hit with those costs later on that might offset the initial advantages that you had from selecting this over a custom integration. And then finally, control. I mean, at the end of the day, you're not in charge of the solution that you've implemented, right? You're using the pre-built functionality that the platform that you're utilizing has outlined. And at any moment, they can withdraw some functionality. They can marginalize pieces of it so the throughput is not as good. You're really stuck at the mercy of the service that's being provided. So obviously a big disadvantage if you want control and ownership of those individual pieces, especially if it's regarding critical processes within your organization, might not be the best solution to choose out of the box. And then taking a look at custom integrations, not surprising, the advantages and disadvantages compared to out of the box are flipped. So the biggest advantage is flexibility. So you're able to build a custom use case, an integration that's specific to the services and the needs of your organization. So you don't have to worry about if service is going to be marginalized. You don't have to worry about if it doesn't provide all of the feature set that you want to accomplish. You have that flexibility to build that yourself and to really extend it to really accomplish any use case that you'd like. Stability. So stability and scalability. I mean, really, you have the potential to never be caught off guard by some downtime or the inability of a custom integration to scale or meet some emerging scenario within your organization. You can scale the application as the needs evolve. So not just creating additional functionality, but you're able to build in more guardrails around that stability to make sure that your application is functioning well and functioning as you intend. And then finally, control. You have complete control over the full life cycle of the integration, from the planning and the development. You can, we've touched on that with flexibility. It's really related to that. You have the ability to flesh out, build new functionalities into an integration, change an integration, pivot away from different pieces of it. You're in complete control of the entire process, which can be a pretty big advantage, especially if you're working in an organization or an industry that changes quite frequently, where the business needs might get antiquated pretty quickly. And obviously touched on previously the disadvantages. It costs money to do this. You need strategists, you need project managers, developers, QA, DevOps, people to manage the integration and deployment of an application or some service that integrates directly into Marketing Cloud or integrates from Marketing Cloud to any other disparate system. That costs money, unfortunately, and time is an offshoot of that, right? It takes time away from other projects that you'd be doing for developers and everyone else on your team to be focused on building out these custom services, simply because it takes a lot of thought and a lot of resourcing to understand the limitations or the functionalities that you need related to this. So definitely something to consider when creating a custom integration. And lastly, resourcing. You have to have the resources to build it if you want to create the custom integration. So it might be great if you have a lot of project managers on staff or strategists, but if your development team is email developers, you might have a lot of trouble building out a full-fledged custom integration into Marketing Cloud or any other external service. So understanding the resources that you have, and if that's even a capability of your organization, can help drive this selection sort of between custom or out-of-the-box integrations and which one that you go with for your integration. So there is another option, which is the most common one, which is why not both? So out-of-the-box integrations can provide, obviously, we just looked at it, some critical services that saves us a lot of time and money and manpower for building out these things ourselves, but they come at a cost of less flexibility, less control. And to that point previously around, having a custom data application that needs to interface into Datarama, right? Maybe that's just one piece of the puzzle, and that's a certain subset of data that we have, but we also have data across all these other well-supported disparate systems. Using both approaches, so having a custom integration that can tackle just that one specific issue, but also save us a lot of time and energy by using the pre-built options available, is the best of both worlds. So we're able to maximize on the efficiency of having the existing integrations that are well supported and stable and can handle large throughput, but also able to support those niche cases where maybe a pre-built functionality just doesn't exist currently. So in relation to custom integrations, we could take a look at a few different types of custom integrations to get a better idea on maybe what one entails and how we would build one out. So the first we can look at is a data integration, which we've already touched on. A data integration just integrates data across disparate systems using different variations of the following stages within the integration. Extract, so getting the data from somewhere, transform, making the data prepared for another system, and then load the data into the end of the system. Then we have point-to-point. So a point-to-point integration uses middleware to enable data sharing between two systems or to serve as an arbiter of some general functionality between two disparate services in a one-way directional flow. So we've touched on that in a few examples, but we'll take a deeper look at that in the next slide. And then we have a hub and spoke integration. A hub and spoke integration it's a methodology for using a fully integrated platform or hub, referred as a data hub, that manages intra-server communication and data transfer through a centralized service rather than individual routing. And we'll take a look at an example of that as well. All right, first let's look at what is a data integration. So we have three types you can see here. These are the most common ones. There's ETL, which will be the one that most people are familiar with. There's ELT and then reverse ETL. And obviously we covered what ETL means, extract, transform, and load in the previous slide. And these all use some different cadence or different sort of routing or flow of the process to create different results and to meet different use cases. So let's take a look at each of these in turn. So first is ETL, and ETL is a traditional data integration whose origins go back many decades. Under this paradigm, data is first extracted from a first-party database and third-party sources, which you can see there, cloud application, such as software as a service tools or cloud apps, and is transformed to meet the needs of the organization before finally being loaded into a data warehouse. First, we take the data from a cloud app, load it into a staging area for transformation before finally loading it into the data warehouse. So in our staging area, we'll enrich, transform the data to fit within the data structures that are outlined within the data warehouse. And obviously the data warehouse could also be Marketing Cloud, right? This is traditionally in web applications, a data warehouse, but it could be another cloud service provider. Another advantage of processing our data like this, and why it's so popular within a staging environment before loading it, is you can encrypt it. You can remove data that would violate compliance requirements like GDPR or HIPAA. So a lot of advantages to doing that, in addition to just making it fit within your overall data schema for whatever platform you're going to load that data into. And you can see finally, the last step is we'll load it into a data warehouse or some cloud service application. So looking at an alternative form of that, ELT, so extract, load, and transform, it's similar to ETL in that it involves the same sorts of processes. But the key difference is the order that the steps are performed and the consequences that are derived from doing so in an organization. This ELT really rose as a modern approach to ETL. It's largely been fueled by the emergence of cloud data warehouses that are both performant, highly reliable, and enables data transformation and enrichment to occur within the data warehouse itself rather than a staging environment. So the difference is, we'll extract the data, we'll load the data into a data warehouse without the transformation process and perform those transformations within the data warehouse specifically. You can imagine an integration into Marketing Cloud being somewhat similar to this, right? We could extract the data from some service, load it into some environment within Marketing Cloud, and then transform the data there rather than maybe having a service layer where we're extracting, transforming the data at the service layer to prepare it for an integration to Marketing Cloud or some data warehouse. So it just sort of reverses the steps in that process. So within this approach, data is extracted directly into the data warehouse or cloud service to be transformed. It means that it uses cloud-based services like Salesforce Marketing Cloud to process structured, unstructured, raw data types. And because of this, it's also a common integration type with data lakes. And so just as an FYI, a data lake is a centralized repo that it's used to store both structured and unstructured data, as well as being a method for organizing very large volumes of data from different sources within an integration. And then finally, we have reverse ETL. So really in the web services space, in the web space generally, the center of gravity for data processes has really shifted to data warehouses in recent years. So their importance providing value as a source of record has potential to be utilized across a variety of applications and solutions like Salesforce or Salesforce Marketing Cloud. That primacy of the data warehouse, which I'm sure that many of you are familiar with and work with, has really led to the emergence of the approach of reverse ETL. So it's like ETL, except imagine the diagram you see there flipped. The centrality of the data warehouse is the difference. So the power of this approach lies behind the centrality of the data warehouse, both as an expansive store of data across various platforms and as a source of data flowing back into these applications as a true analytics operation loop. So you can see in the diagram that we're operating the data warehouse as the initial data store that we'll use to extract and process data with a sort of hub and spoke methodology, which we'll cover in just a moment. And it takes our centralized data store, the data warehouse being the central component, and really cascades that data out to all the various cloud applications and service that we use. So yeah, to summarize, like ETL, but with the diagram flipped, the centrality being on the data warehouse to power those external applications, like Salesforce Marketing Cloud, with data from that centralized source rather than the reverse. So another integration, and I think for most of us who've built integrations into Marketing Cloud, either through the API or just using some standard scripting tools in the platform, this is probably the most common one that we have to deal with. So point-to-point integration. So a point-to-point integration, it's also known as a one-to-one integration, are those that use some middleware or can just be an existing service. Postman could be the middleware to enable data sharing between two systems or to service some arbiter of general functionality between two disparate services in a one-way directional flow. So you can see from this diagram, like Salesforce Marketing Cloud going to application one, right? It's a one-way data flow that performs some functionality, right? It could be taking assets from Salesforce Marketing Cloud and pushing it to another cloud app. Could be pushing data, could be anything, right? But the main thing is that there's not some bi-directional flow between those two services. We're just making a call, and Salesforce Marketing Cloud is starting some action in some other existing service. So this facilitates the transformation of data and the mechanics of transporting the data. This integration type is the simplest to set up, but it's not exactly scalable or flexible. So point-to-point integrations, unfortunately, are very tightly coupled. So they are coupled completely to the application or service that they are calling the API or whatever integration service that you're using for. So they can't really be recreated or generalized. They're very specific to some functionality, right? If I have an existing external CMS system and I'm going to copy content builder assets to this other system, I can't take that same integration and use it for an entirely different CMS system, simply because the mechanics of the integration, while it may be the same for Marketing Cloud, I know how to gather the assets and what to post. The API capabilities, endpoints, everything could be different between those two disparate systems. So when we say tightly coupled, we mean that it's really tightly coupled to the use case that you developed it for and the platform that you're integrating with. So it's simple, and we have a lot of, there's a lot of value in creating some simple integrations. So, it might work if you want to just have one CMS, right? A point-to-point integration is perfectly fine to accomplish some one-off task, but it spirals out of control, right? As you can see from this app, we have 4 different applications maybe that we need to interface with, and they all need to share data together, and maybe we push something to the Cloud App 1, but that needs to trigger some action in some other platform that triggers some action in some other platform, right? And you can see how it would spiral out of control pretty quickly. A lot of different mechanisms to test. And so you need, the first route that goes to App 1, App 4 is dependent on that, right? Because it's also dependent on App 2 and App 3 to get its data. So you have many points of failure related to it. It's can be very complicated to debug. So it's very good for very isolated use cases and things where just a simple integration is sufficient to accomplish some needs. But if you have a big web service architecture and you're integrating across a bunch of different systems where Marketing Cloud is an individual piece of the puzzle, maybe not the best integration type to use if it's going to expand beyond a pretty simplistic use case. And to that end, that is why this methodology has become much more popular. And I'm sure that many of you have either created or worked with an organization that uses a hub and spoke model. So in contrast to the point-to-point integration, a hub and spoke methodology uses a fully integrated data platform called a hub that manages all the different communication from apps through a centralized service of data transfer rather than individual routing, right? So Salesforce Marketing Cloud needs to, in the previous example, right, we needed to call App 1 that calls App 2, 3, 4, et cetera. But in this scenario, we only need to contact the hub. So the hub contains all these different capabilities for ingesting data across disparate services and then pushing that data back out to take some action or functionality in the other systems without requiring such a complicated series of events. So rather than disparate services connecting to each other via these one-to-one discrete integrations, here the services are all connected to that centralized hub through lightweight connectors that facilitate the request from Salesforce Marketing Cloud. So I could, in the scenario of the CMS piece, Salesforce Marketing Cloud could just dump CMS or content builder data into the hub, right? I don't have to worry about how the other app is getting it. I just need to keep that one connection flowing, and then the hub can mediate those requests through connectors with the other applications that can reference the data. So App 1 won't need to call App 2. They'll both reference the same data source in the hub, which keeps it not only centralized and a lot less points of failure, but we know that the data is fresh for all of the applications, right? There's no latency between the apps or integrations. So this allows us to make significant modifications to the connection logic. What if in Salesforce Marketing Cloud, we wanted to add Journey Builder, JSON schema? We want to dump that into another system or really anything. We want to move email assets and image assets. It doesn't matter. The main thing is that if we make some change, right, in the previous approach where we're creating some integration with another system, we can't really make a change. Unfortunately, it might not work with the capabilities. It might require a separate point-to-point integration, right? So now we have one route that handles one integration, then we have another that handles other assets in Content Builder. Whereas here we could just extend the capabilities of our existing integration to the hub, and now the hub has an enriched data source that it can now share with the other applications that we don't have to worry about. Can Marketing Cloud easily integrate with them? The hub can integrate with them because the systems can be as disparate or different as they really need to be. That we can create lightweight connectors that can sort of accomplish each individual use case and not really worry so much about changing one thing, breaking everything else. So another aspect of this approach is really what's become the widespread availability of integration platform as a service, which combines all the capabilities of the hub and spoke approach in tandem with multi-tenant cloud services. So multi-tenant cloud services, probably pretty familiar to everyone here, seeing as Marketing Cloud is one. These providers host applications, servers, and data, provide integration tools, middleware solutions that can really accommodate the entire development lifecycle. And it's a user-friendly version of this. So the main thing is that you don't have to go out and build the hub, although you certainly can, and there are plenty that do, especially if you meet custom needs. This was something we touched on for the out-of-the-box versus custom integrations. But there are a lot of platforms as a service that will serve as that centralized hub that allows you to feed data into a centralized source and connect it to disparate platforms that can utilize that data and action on it to really create a cohesive ecosystem that's constantly updating and changing and meeting all your business needs. So finally, with taking all that in, the different integration types, what are some considerations when you're thinking about creating a custom integration? First, what capabilities are present in the systems you wish to integrate, right? I mean, maybe you only want to use REST APIs, right? And you want to create data extensions in Marketing Cloud. There are obviously ways around doing that that you can get through using the REST API, but it's not natively supported, right? I mean, mainly it's related to the SOAP service. So, and in an external service, right, you might want to send an email when something occurs, right? But if that capability isn't present within there and you have to create it, it's just something to consider, that you can't really integrate systems if they don't have the capabilities to integrate. They may not even have an API with an external system. So you need to understand that before you can even consider creating some kind of custom integration with another platform. Secondly, is every process within the integration automated, or will manual intervention be required? So it doesn't make a whole lot of sense to have some complicated integration if every time an action takes place, someone has to go in and retrieve data or dump it into another platform, really perform any manual action. So you obviously, for custom integration, you want to make it as automated as possible, just to save yourself time and really to be worth the effort of creating one. How does the integration fit within the overall process or flow? So obviously you need to understand your current processes. So it might just be how someone signs up on a website, how that data needs to be transformed, or where it needs to go after that, right? Maybe it goes from the website to a service layer, from the service layer to Salesforce Marketing Cloud, gets transformed in Salesforce Marketing Cloud to prepare it for the data warehouse, and then SFTP'd out and then loaded in the data warehouse. But you need to understand that process flow before you can understand how an individual integration will fit within it. So the integration that we might be responsible for is creating that service layer and passing that data, but we need to understand the entire process to know what structure, how it needs to get over, what cadence it needs to get over in, everything around the overall process to understand how effective that integration can even be within the overall process or flow. And then finally, what resources will create and manage this integration? As you can see from the things that we've just gone through, it's more than a traditional kind of capability that we use in Marketing Cloud. It's really thinking about Marketing Cloud as just a provider in the cloud services space, and how we can utilize the functionality of this platform to automate and bring together all these different sources to create more effective, marketing experiences for the customers and the people that we market to, but also more efficient within our organizations. But it does take a different kind of resource set to accomplish that. So if you have, like I discussed with the service layer, you'll need developer resources who can manage the development and deployment processes and create effective documentation, do error handling, maybe some things that we don't necessarily do when we're working within the platform, but when you're managing custom integrations, obviously it's a very important skill set to have. So understanding your resourcing will really dictate what capabilities you even have to manage a custom integration. So moving on from that, let's take a look at APIs. So what is an API? An API is an acronym for Application Programming Interface, which is a software intermediary that allows two applications to talk to each other. There are several types, such as open, partner, internal, and composite. Before we look at those types, I like to think of an API as being like a menu in a restaurant, right? You know what you want the meal, right? But you don't need to go tell the chef, okay, this is the ingredients you need together. This is the instructions for preparing all of them. That's implicit in the menu. And so the chef understands that when you say, I want, some dish, you don't need to provide that other information because it's understood from his perspective what next actions need to take place and what the response should be. In this instance, it should be fresh food. Back to you. So it's really just creating an easy interface that I can provide simple instructions that can yield complex results based on a shared understanding between two parties or two systems in most instances. So first, there's open APIs. Open APIs, can probably guess by the name, they're generally just available to everyone. They're external or public APIs. There's lots related to weather. There's dark sky API that can provide information on cloud cover or what the temperature is, things like that. It's really just open ones that are available to the public that allow you to easily access data, including government data, public data, just things that aren't going to really be proprietary. That allows you to rapidly innovate on an existing solution. You can extend functionalities just because you're able to access large data sets that are available to extend some application or service. Then there's partner APIs, which APIs that are open are wide open. Unfortunately, partner APIs are a bit more exclusive. So when you use a partner API, it's only available to authorized developers or organizations that will consume the API. Partner API is usually for business to business communication or company to company activity. So like if we had a business A that wanted to share customer data with their marketing agency, which would be business B, which is wholly separate from business A, using a partner API, business A can provide a method for business B to consume that data, right? So it's not available to the public. It's an API between two businesses where they're able to communicate and share data that maybe they don't necessarily want everyone to have access to. Finally, is an internal API. Marketing Cloud has many of them, as I'm sure most of you are aware. So it's an API that just opens the backend data and application functionality for developers to use and manipulate, but is wholly housed and accessible only for users of a company or organization. So you're not sharing it with other businesses. It's not available to the general public. This one's locked down and only provides functionality directly related to the internal processes of your organization, just because they may be sensitive in nature, have access to data that you don't want other people to have access to, or perform some functionality in the platform that you don't want to extend to a wider user base, either through security concerns or through it not being widely tested and able to handle a large volume. And then lastly, there's composite APIs. So these just combine multiple APIs to create a sequence or a series of events within the platform. There's an example in Salesforce CRM, right? You can create multiple objects in a single request. So I can create an account and then a case record through the Salesforce API with just making one single API call. So I'm able to combine two disparate APIs into a composite request that performs multiple pieces of functionality with just one single request. All right, now taking a look at the types, let's look at different APIs. So we'll examine each of these briefly, but first there's the SOAP API. So it's a messaging standard protocol that uses XML to declare its messages and relies on the XML schema and other technologies regarding its structure. There's the REST API. So RESTful APIs represent the state of a given resource, state just being information about the resource. When the RESTful API or service is called, it will return the representation of the resource's state back to the client in some form, JSON, XML, or some other format. And then finally, GraphQL. So this is a newer one that was created by Meta or Facebook, a query language that is used for interacting with APIs. So in GraphQL, a set of information is interpreted within the context of a graph. And we'll do a quick example of what that is. So first there is SOAP. So SOAP uses a WSDL or web service definition language, just a set of instructions in order to streamline procedural details when processing requests. It differs from the other two in that it is protocol agnostic. So it can function over a variety of different services like HTTP, SMTP, TCP, or others, as needed. And its structure consists of four main components that we'll look at in the next slide, but they are the envelope, the header, the body, and a fault. So working with SOAP requests and responses is complex, especially when they're used in raw XML form. I can't speak for everyone, but it certainly can be difficult for me to parse it out mentally. But fortunately, several languages make it a lot more efficient and reduce that level of complexity, like the .NET platform hides XML to a large extent, makes utilizing it less reliant on understanding XML, which can be important for people that can't grok it quite easily. But yes, the main thing is it's protocol agnostic. It uses the WSDL, and the WSDL is pretty much like a contract that's signed between the provider and the recipient of some service, kind of like a cell phone service contract. This contract or method signature for programmers allows this process to publish a machine readable document that helps define endpoints and all the corresponding procedural details. It really makes everything more efficient so that we can send a request that the service that we're sending it to can understand it. So that's the point of the WSDL. So let's take a look at the four main components. So the four main components of a SOAP request is, first, there's the envelope. It's required in every SOAP message. It's the main wrapper, sort of like a envelope that holds a letter in the mail. It needs to be opened before the other contents and closed once the content has been entered. The envelope is required in every SOAP message and must be the root element, encapsulates all of the components within the message. So just think of it as a big wrapper, needs to be opened, needs to have closing tags, and really holds everything together. The header element in a SOAP message is a child element of the envelope. It's an optional element in a request unless stated otherwise in the WSDL. It contains application-specific information like security information, encryption, can be used for authorization. One important attribute, though there are several that can be defined on a header element, is encoding style. So the encoding style attribute identifies rules that are used to encode the SOAP message. This attribute determines the serialization rules that could be applied to any element within the SOAP message. So basically, it just contains application-specific information related to the request. And then we have the body. The body is like a letter, using that analogy again. It's the part that contains the main purpose and the majority of the relevant content related to the message. The body sits within the envelope and contains application-specific and defined XML data that will be used within the message. So if you're making a SOAP call to Marketing Cloud and you've used this before, you'll know that the body is where we're defining the actual meat of the request, right? What maybe it's a triggered send we want to activate. That's where we're defining what the triggered send customer key is, the data we want to pass it, and sort of what type of request, right? Do we want to update one? Do we want to execute one? That sort of thing. So it's really just everything related to the actual structure and the functionality we want to accomplish for an individual request. And then the last one is fault. It's an optional element, not used entirely too often, but it can convey relevant errors and status information regarding the request. So we can set the kind of errors that we want to return to the response if some event takes place. It can be easier for debugging, but certainly not required to create some kind of SOAP call within the platform. So obviously some SOAP object examples that you're probably familiar with within Marketing Cloud. There's the triggered send, so we can execute, create, update triggered send definitions. There's the send object. So the send object can return information related to an individual send, so we can aggregate maybe opens, clicks delivered by a job ID using the API rather than querying on the sent data view. Automation, we can create, update, manipulate automations. Same with data extensions, and then subscriber. So these are actions that do have some, not all of these, but some of these have some REST functionality built in, but the extensive amount of the functionality is built to be handled by SOAP requests within the platform. So this is a REST request. So as we said previously, RESTful APIs just represent the state of a given resource. So think of the state as being just information about a given resource on the server whenever you request it. So if I requested and made a REST request that says, give me this content from Content Builder that has a certain ID, right? I want to return that ID. The state of the resource will be things like the name of the resource, when it was last updated, what the HTML content of that resource is. So it just provides an overall representation of a resource on the server at a given time. And that's really what underlies what REST APIs do, right? They return or update or create a status or state of a resource on some server, and then return some response in kind to let the client that called the service know that there was an error or some action was taken on the server. So unlike SOAP messages. The request and the response sizes for REST are much less verbose, way easier to work with, and it's much quicker, obviously. So we can just see here using this diagram, we have some client, which would be, could be Postman, could be a cloud page, could be anything, could be a command line or some service. Makes some requests, right? It makes a request based on verbs. So it uses a get, post, put. There's also patch, which is a slightly different variation, and delete. So it has some endpoint. So there's an HTTP method and a URI. So with REST, individual resources are stored on an existing route. And so if you see in the Content Builder APIs or Journey Builder APIs, right, they have a defined URL that is able to access that resource. So you might have your client specific one and then, interactions. So when you're defining that URI, it defines on the server the route that you're going to use to access a given resources state. And then you use the verb to tell the system what you want to do with that given asset, right? So if you specify a delete method on an interaction ID, right, you want to perform a delete on a given interaction, and then it's the ID that you want to access on the REST server to perform that action. And then the REST server contains all those resources, takes that verb plus URI, and if it's authenticated, it will send back a REST response, of 200. Maybe it's been deleted, whatever response is relevant to the request, or could be an error, right? Bad request or something like that. But basically, we're making a request to the server with a verb using an HTTP method plus some URL to access it, and then it returns a response based on our call. So the composition of a REST request, first there is the request URL. So the request URL defines both what service you are making a request to, as well as the type of resource or functionality that you are attempting to access, which we just highlighted with the Journey Builder and Content Builder examples. Contains a few basic pieces of the request URL. First is the base URL, which is the root domain or subdomain that you're using to make a call or receive a response from the server, which would be your client-specific endpoints like the auth or REST endpoints that are available within the setup for installed packages. Then there's the resource, which is appended to that. This is the route you are calling on the service to let it know exactly what resource you're trying to access. So it might be asset for Content Builder or interaction for Journey Builder. So that next little piece lets the server know this is the request that I want to, or the resource that I want to access. And then there'll be the path. So this is required by an API and acts as part of the REST endpoint. It's a further specifier concerning the resource that you are seeking to access. So it might be categories, right? I want to access Content Builder, but I also want to access a sub service of that REST API, which might be a category or an asset. So that's a required piece to let the service have more information on the request that you're making. And then finally, you could have a query string parameter that can be specified after the path parameter and really just refines the subset of data to be returned when certain method types are used. So maybe I only want Content Builder assets where the name has the word test in it or something, right? We can just be more granular to limit the response that we're getting back from the server. Next is a request header. So request headers are used to pass additional information in the request using name value pairs. They set the context of the call that you're trying to process and provide the required information for the call to take place. I think most important for the work that we generally do, things like content type, right? I want to know what kind of content type I want to pass and return from the request. Authorization. So, if I'm making a service into Content Builder or Journey Builder APIs, I need to authenticate the call. So first I have to generate that access token. But when I make the subsequent call to actually perform some action on the server, I need to authenticate by passing in an authorization header within the request headers. And then finally is the request body. So request body is used to send and receive data for our request. It's not always a required field, for instance, with GET requests, depending on the service and method being used, but defines information in put and post requests around the resources we are working with. Right. So if I want to create an asset using post on the server, I need to provide information about the asset that I want to create. Right. If I wanted to create a content block with a post request into Content Builder API, I need to specify the HTML content, the name, information and metadata around the resource that I'm trying to create on the server. Otherwise, the server doesn't know what resource to create. All right. So there are 4 or 5, I guess, if you want to count patch as a separate one, REST methods. So the get method is first, it's used to retrieve a representation of a resource rather than creating a new one on the server being requested. So basically, using this method, you can use a request body. It's not required, but it will usually be ignored because it's not considered to have quote unquote semantic value for the request. Basically, I just want to access the server and say, give me this resource and give me its representation right now. Give me the current state of this resource using a GET request. Then we have put and patch. So the put method is commonly used to provide an update action on a server resource. So I want to update some individual piece of that representation. Using this method, you can specify an updated representation of the asset within the request body and targeting that specific request URI that we discussed in the previous slide. You can update that representation of the resource on the server, so I can change its state. Maybe change the HTML assets, update the name, whatever related to that. It can also be used to create a resource where one doesn't already exist, right? So if I specify a specific URI, like I say, for this ID, use a put method, and I want to update the name on it, right? But maybe that ID doesn't even exist. Put can create a new asset on the server. The patch method, similar to put, it's used to modify an existing resource on the server, but unlike the put method, the body of the patch request holds a set of instructions that are used to describe how a specific resource on the server should be changed to create a new version of it. So, when using put, we need to provide the complete representation. And that's the biggest difference between the two, is that if I want to update an asset with a put method, I need to provide the complete representation of that asset on the server in the request body to update the asset. Whereas patch, I can only, I only need to provide really what I'm changing, right? So if I only, let's say I had an asset, right, and I'm using a put method, I need to provide the complete representation of the asset, even though maybe I'm only changing the name, I still need to include that other data to update the resource on the server, even though it's not really necessary for the change I'm making, whereas patch maybe only provide the name, right, and the ID and the resource URI to update that asset. So it's a little easier to work with using patch. Post is most commonly used to create new resources on the server to further refine the result that's returned when a GET request with a query string. Like, we can use post methods in Content Builder complex asset query. So maybe I need to return all assets in a category ID that also, the content contains some substring, or maybe the name contains some substring, right? There's complex filters that maybe aren't really fit for a GET request, where it would be using a query string would be too verbose or maybe not even supported for the functionality that I want to filter on. A successful post request, once I've made the call to the server, it should create and associate a new resource with some parent element and assign a unique ID that I'm able to use to reference it in the future, maybe in a GET or put patch request. So it just creates some new resource on the server. And finally, pretty self-explanatory, the delete method. It's used to delete some resource on the server when a request is being made. And like a GET request, it can have a request body, but usually it doesn't have one to prevent confusion and just makes the request a little more heavy. So some REST APIs in the platform that you might be familiar with. We've covered the first two. There's also data events, right? We can push synchronously and asynchronously data into the platform. It's a lot easier to do with the REST service than maybe using a traditional SOAP method. So adding data to a data extension and then being able to check on the status of the upsert request. Mobile Connect, the QMO API, we can push messages, create context on a list, lots of things related to that. Transactional messaging, sort of a better approach for triggered sends. We're able to create those interactions, manage them directly within the API. Certainly a lot easier if you're building a service that interacts with Marketing Cloud, but then also push those messages out and report back on them in related to metrics. And then finally, a new one that's still beta is the S3 file trigger. So we're able to create a Lambda function inside of AWS that can automatically push a file from Amazon S3 directly into Salesforce Marketing Cloud. It's a new one that's been recently added to the docs, but certainly an interesting one that could be accessed via the REST API. And then finally, it doesn't have quite as much applicability, obviously, to Salesforce Marketing Cloud because Salesforce Marketing Cloud does not possess a GraphQL API. But several popular services do, right? GitHub is one. Really, any of the social media platforms have some kind of GraphQL API, and it's definitely a different way of thinking about accessing resources on the server, and certainly much more efficient if I wanted to get really disparate pieces of data within a single request. That makes a lot more sense than like calling a service multiple times. So GraphQL is a query language that is used for interacting with APIs. GraphQL is a set of information is interpreted within the context of a graph. So you can see sort of by the logo of GraphQL, all the data is interrelated in a graph structure. So rather than being a defined, well, we looked at REST APIs, right? We had a server with resources listed on it that had these IDs that are mapped to the service. You have to call the individual resource through the URL to be able to access it. GraphQL doesn't really work like that. GraphQL relies on a series of databases that power and create a graph of how the data interrelates to one another. And so having that system, what I'm able to do is take different pieces that aren't related to one another and return them in a single request. So I think a good example would be, like, let's say just a simple database. I have a list of employees and their managers, right? In thinking about if I wanted to retrieve information about an employee, let's say I wanted to retrieve who was the employee's manager's name, right? Think about REST, those are two different services, right? We might have a route for employees and we have a route for managers. And so if I want to get individual manager data related to an employee, I make a GET request to the employee route resource for that ID. And then it gives me a manager's ID that relates to that person, right? And then I take that ID and I look up a second request to the manager's resource, and I get the state of that manager, and I'm able to access their name. That's two calls to retrieve what should be somewhat simplistic data. In GraphQL, I can define the schema. So a scheme system, which is what defines the graph. I'm able to just access that data programmatically, so I can nest requests and say, I want an employee for this ID, and then give me all the subsequent manager data, and maybe even 5 levels down if I wanted, the company that manager worked for, or maybe they have work history, or whatever the case is. It's a simple example, but it's a much more efficient approach because now I've taken what would be multiple requests to a server, and it could be even more complicated than that, right? Maybe you need 10 REST requests to access some kind of nested data that all interrelates with one another. In GraphQL, that's simplified that a single request can return disparate data sources across different platforms. So with GitHub, for example, it's very efficient that I'm able to, get information about commits, repos, individual files, everything. I can return it all within a single request, which is much more streamlined, efficient, and not entirely popular, I think, completely across services, but it's definitely growing in popularity and can be a joy to work with if the data is too complex. So that's APIs. Webhooks. Webhooks are referred to as web callbacks, or reverse APIs, just a method that allows an app or service to send real-time data to another application or service when some given event has occurred. There are examples of that. Within Salesforce Marketing Cloud, there's the event notification service. So I can subscribe to an event, and that's really the key, is that you can subscribe to some event to take place in the platform. Lots of services do it. GitHub has some, right? So I could subscribe to a commit event in GitHub and say, whenever a commit has occurred, I want you to hit this endpoint, right? I want you to call some other service and let it know that something has happened. And that's really the main thing here, is that whenever an event has taken place, it will automatically call some existing service or application, right? We could use a cloud page, so we could have it. And in the book that we wrote, that's the example we went with, right? Whenever I make a commit into GitHub, I can call a service in Marketing Cloud automatically that can fetch GitHub data around the commit, maybe a file, and I could take that file and insert it into Marketing Cloud, right? Which is a lot more efficient than me constantly checking whether something has actually happened in GitHub before I do something inside of Marketing Cloud. So it's a way to really link disparate systems together to take advantage in real-time data. And so let's take a look at an example. So this is an example of how a webhook compares to something like continuous polling, which is just making a series of REST requests or SOAP requests, I guess, at a cadence to determine if some event has occurred. It could be any event. We can use the GitHub one, or it could be anything in Marketing Cloud. Has data been added or anything like that? Has a file been dropped? So you can see in the first example, we have a client, which is us making the request to the server and say, has that event occurred? And the server says no. We have to make a second request. Has it occurred? The server says no. Finally, some event has occurred, a GitHub commit or some asset's been loaded or anything like that. And then finally the service says, yes, the event's occurred, and then I can process with whatever action I want to take. But you can see it's inherently inefficient. I have to call the service constantly to understand if it's occurred. And like between the second and third step, what if 30 minutes I'm calling it, maybe the asset's gone, maybe it's changed. The data can be inherently, the data is stale when you use continuous polling. So you can see on the right, a much more efficient solution is I subscribe to some service and just let that service know that whenever some action, and I define the action that I want to subscribe to, whenever that action has occurred, send the data out there. I mean, just even looking at the number of requests involved, it's obviously more efficient, right? I don't constantly hit the server and asking it for requests, which can overload the server, slow down processes. But also my data is real time. I know it's always fresh, right? Because I'm getting it exactly when the event occurred. I don't have to worry about the latency between the last time I requested the asset. I know that whenever I'm sending that data, it happens automatically. And so you can use series of webhooks, right? I mean, there are webhooks for Slack, webhooks for Discord, GitHub. Many platforms have some form of subscription event that can take some action whenever you're working in the platform. So I could create a commit that posts in Slack that sends out an email from Salesforce Marketing Cloud that posts in the Discord channel, and it does it automatically. And I don't have to do anything, right? It's connecting all these disparate systems through easily programmable things. I can connect webhooks to webhooks, without any coding at all. So I can create this chain of functionality that provides instant notification, visibility, can make processes more efficient, all with configurations in existing services. So it's a very powerful tool to have, I think, in the toolkit. Like I said, Marketing Cloud has the event notification service where you can create subscriptions to send events and tracking things, but hopefully that's something that'll be expanded on in the future. And we touched on it, but a webhook advantage over a traditional API is it allows an action to occur immediately after a given event has occurred, ensuring that the information passed is not stale, requires significantly less resources to achieve the same action than continuous polling, because we're not hitting the server multiple times, and a more efficient approach for linking event-based integrations, and allows for multi-chain streams with little initial setup, which we just touched on. All right, finally, we have design patterns. So design pattern is, for an application, it's really the flow from some initial interaction through changes within the application, and then finally back to some change state with, to the end user. Could be, a general flow that I submit a form and some action takes place and it processes data on the server, upserts it to Marketing Cloud or wherever, right? And then updates the front end to let me know that the form's been submitted, right? That's a flow. So it really defines the ways in which we build, test, develop, deploy any external solution to Marketing Cloud. And there are several different models, and certainly they're discussed in the book that Greg and I wrote, but we can take a look at one common, probably the most common architecture, which is MVC, stands for Model View Controller. So it consists of 3 parts. Model, which is the data required to display in the view. So representation of the critical information used within your architecture. I think with a lot of these examples from this presentation, you can try to envision all of this in the same way that, in Marketing Cloud, right? So a model could be a data extension, right? Data extension contains that critical information, and the view could be a cloud page. So I have a cloud page that displays maybe that data extension information. So it just outputs the data extension information. And then I have a controller, which might be a code resource JSON script, right? So some action takes place on the view. Maybe it's a refresh button. So there's a refresh button on the view, which is the cloud page. I click refresh, it calls the code resource, which is the controller. The controller takes information from the view or the front end, which in this case would be the refresh button has been clicked. So it takes that action and then it calls the model and says, return either maybe add a row, that might even be a better example. But basically it takes information from the view, transforms it and prepares it to update the model, which the data extension, and then that data extension, which is the model, then updates the view, right? So now we've refreshed it, and then there's more data in the data extension than we initially saw on the cloud page. So the view is updated to show that new data. So it's a common architecture, just that you have a view, which is the front end, some controller action that is able to take and process events from the view. So it just reads events from the view. and then updates some model, database, anything that contains the critical data for that application. So it's a good architecture, and it's a very common one because it has a few different advantages. One is the separation of concerns. So the view is different than the controller, and the controller is different than the model, right? I can update them each individually. So if I had the cloud page, the resource, the data extension, right? If I want to update the controller, I don't have to worry about updating the view or the model unless some change is required to that. It shouldn't be, just based on this architecture, but it separates the concerns between all of them. If I want to handle the controller logic and how events are processed from the view, I work with the controller. I don't need to work with the view. I don't need to work with the model. I work with the controller. So it's a separation of concerns within an application. And the responsibilities for each are divided between the client and the server, client being the view, and in some sense, the controller, and then the server being the model, database, data extension, that sort of thing. And then obviously with that, each component can be tested separately, right? So I can alter the view and test it and make changes, and I haven't messed with the controller or the model. So everything is sort of isolated in its own individual piece. All right, so let's take a look at an example of an MVC architecture. So imagine that this is in Salesforce, we have a Lightning component. So I'm a big fan of Lightning components. They can extend the functionality of the platform pretty easily. They work well, obviously, with Marketing Cloud, and it takes away all those concerns with hosting. And there's some mandatory testing in there that you have to have for your Apex classes. So it's a very handy tool. But here we have just a simple widget, right? We want to enter a person contact ID, and it will search a data extension, right? So we can enter some ID from a contact record in Salesforce, click our little icon here, and then we should be able to find all records in a data extension related to that, right? And that's the functionality that we want to accomplish. Let me pull up the code that we can walk through. Okay, so we'll examine this in an MVC architecture. So first we have a component file, right? And a component file is what you're seeing. It's the front end, right? It's the view. So you can see this is where we're having our input, right? We want to enter a person contact ID to search, where we have our icon, basically just the front end of the application. And maybe we'll have this here, right? When we return data from the server, we want to output that data here. So it has the ability to be refreshed from the model, which we saw from the previous slide, that it's getting, the view is calling a controller, the controller calls the model, and then this is how the model can update the view, right? Now we've made a request to Marketing Cloud to retrieve that data extension data, and if we've got any, let's show it on the view. So the view is updated from the model. So yes, this is the front end of the application, contains everything we want to see, but here's a click event for the submit. Like, we actually want to submit the results, right? What action does that take, right? That calls a controller. So the controller is just contains a function, and all the controller wants to do is take some event from the view or the component right here, the front end, and then take some further action with it, right? We want to update the model in this instance, which means get data from a data extension and return it back to the view so we can show it, right? So we have a controller file that just contains a simple function, and really Lightning components are more of a model controller view architecture, or model view controller, because this controller just calls another controller, but it's the same general process, right? I have some piece, the component file, which contains my markup and information that maybe I want to display on the front end, calls a controller file. That controller file here, it calls another controller file. It processes an event right from the front end, which is a click, and then it will just call some back end piece of code, right? It calls the model here, and so this will just we'll call a component on the back end called search request based on the search ID, which is just the person contact ID, right? And this will make the actual call to the model. So this makes the call to the model. The model is a data extension somewhere in Marketing Cloud. So what I've done is here, I've taken the view. I enter in some person contact ID. It's just some front end that the user can interface with. I click on the button, right? It calls the controller file. The controller file is meant to process and update excuse me, from the view and take that event and then use it to call the model. The model is calling the data extension. The data extension has all these records, right? And now we're calling a filtered representation of it and say, hey, data extension, give me all the records you got for this person contact ID. And then the data extension says, here you go. The model takes it and pushes it back to the view And we won't walk through an actual implementation of it. It's just for testing, but you can see that, we'll enter the ID, it follows through there, we get the data back, and then we can show it on the view. So the view has been updated by the model through the controller based on the first interaction of the view. And that is the essence of model view component architecture. Is you just have a front end, you have an intermediary that can handle the events, and some database that is serving the data that shows up on the view that can be changed based on some action handled by the controller. So that is that's an example of MVC, but like I said, there's model view, view model, model view. There's a lot of different architectures that you can go with, but this is definitely the most common one that you'll encounter if you're creating custom applications for Marketing Cloud or any other service. So certainly a good one to know. And then I guess lastly, before we move on to the final thoughts, is it doesn't, I guess creating custom integrations doesn't just have to serve a business need, right? It can be something that makes your own processes more efficient. That doesn't even have to have client sort of facing or customer facing resources, right? You can create dashboards or tools. There's a lot of great stuff out there that the community is creating related to libraries and package managers and things for web tools that don't necessarily work with Marketing Cloud, but can improve our ability to be effective within the platform. An example, so here's an example, one that I sort of a demo I spun up for this. So maybe we could create a dashboard, right? I think one of the big challenges for me at least is envisioning what we can do with the platform. So here we can take a bunch of disparate services. So maybe I'm calling the Salesforce Trust API. I want to get information on releases. Maybe I want to call Stack Exchange and see what the most recent Stack Exchange Salesforce questions that haven't been answered, and they have a score and who wrote them. I can bring everything face up. Obviously this is not as useful for our work, but it's able to bring all these different pieces together related to the things that we do and provide some, enhanced efficiency and functionality that I can get all this stuff face up without having to be in an external application. Maybe I want to get information for a platform on like contacts remaining in the account, or provide automated functionality so I could delete a contact, delete a list reference, right? You can enhance your own workflow and capabilities by extending out these functionalities of things in the platform through a web application methodology using common tools and architectures, kind of like MVC, which this is an MVC application that we can use to enhance our capabilities within the platform. All right, final thoughts. Testing, and more testing. 10 more testings in there, maybe. Testing is important. I mean, the most important thing is that you have, before you're creating any solution, and I know we've covered things at a high level here, but before you're creating any solution, just have a testing plan in place before you write a single line of code. Like, you should know the output, the final end state, what the components should do. Everything should be identified and tested before you even begin to develop anything. So not necessarily related to custom integrations or integrations definitively, but just always something to keep in mind that through any solution, and we didn't even cover it, I think, in the MVC piece, but testing is critical and definitely something that should not be taken lightly. Second is, why does any of this matter? I mean, we've discussed a lot of things, and maybe it seems tangentially related to Marketing Cloud. It's not something you use in your daily workflow, so maybe it's not something that is that interesting or that you need to know about. But when we understand and come at Salesforce Marketing Cloud as just another provider in this space, even though we're developers and we work on this platform, and obviously it's our main focus, we can really extend the capabilities and provide functionality that our companies or clients aren't even really aware is possible, right? We can extend the capability of the platform, and that's really where Salesforce Marketing Cloud is so powerful, is that it gives us the tools to do that through a robust set of APIs and through being just a platform that really opens up all these different possibilities. If we don't have that background in building custom integrations or web application architecture, we're leaving a lot on the table by not being able to fully utilize the platform to its capabilities. And there's certainly much more than I covered in this slideshow, but it's certainly important to not see it as just I work for Salesforce Marketing Cloud, but I am a developer who uses Salesforce Marketing Cloud in the broader context of web application development and just data integration and building solutions for clients. And then lastly, share your knowledge. There's a lot of great things I've seen in this community of people sharing use cases that maybe you wouldn't consider, and custom integrations, and just really lots of great stuff. So if there's anything that you've got, going on, definitely don't ever hesitate to share it, because it can inform all of us to do really cool things with the system that maybe we hadn't considered in the past. So yeah, definitely feel compelled to share your knowledge when appropriate. Okay, thank you. So you can find me at jasonhanshaw.com if you ever want to email me, and don't forget to check out the book from me and Greg Gifford, Automating Salesforce Marketing Cloud. It's available on Amazon, and that's just a shortened link to get there. Any questions? That was quite a lot to digest, I'm sure.
Thank you, Jason. There is one question on chat, and there's a great session, by the way. I was taking down notes myself. We've covered a lot, and really appreciate your knowledge and all you shared. So if anybody has any more questions, feel free to drop them in chat. Otherwise, you can always reach out to us or Jason directly if you have follow-up questions. But the question we have from Yash, and he's asked two, but one of them we've already covered. The second one, he's asking if you have any documentation with examples around the APIs. If so, he's requesting a link share.
Sure. I can. So, I mean, the best one is just the docs for, assuming you're referencing Salesforce Marketing Cloud. You just drop the link in there. Just really go to the APIs overview doc, and you can find all the different REST routes that you can access each individual resource or those resource paths. So there'll be a REST API tab, or content builder, journey builder APIs, mobile connect APIs, all that information. And then there's a wider REST reference, and the REST reference will contain like each individual route for creating a category, retrieving a complex asset query, deleting contacts, really everything. And once you've got the basics down of how to formulate a REST request, really accessing any resource is pretty much the same thing. The only thing you need to know is the schema that Salesforce Marketing Cloud expects. But if you've got the basics down for, get being retrieve a representation based on the resource path that I provided, or post being created one, or delete or put or patch, once you know that, it really doesn't matter the route. Like, you can approach the documentation and say, there's all these different resources and routes, but I can use a common set of tools and a common set of knowledge, knowing that what these different methods are, and that how I'm accessing a REST request is applicable to all of these different routes. So you're able to, creating a contact and, creating an asset and content builder, two very different things, but through the API, they're really not that different. There's just a different structure in the data that you're passing over. And you should also be able to find the SOAP API objects in there, I believe, under SOAP Web Service API. It'll have, just some sample code for some SOAP calls, which is certainly helpful. And how to get started with the SOAP API, I believe there's some SDK information in there, but under objects, you'll see all the different objects that you can work with under the SOAP API. So that'll give you a good idea on capabilities and what you can do with REST versus SOAP. And even though there are some limitations with some of the SOAP objects, you can't update some, you can only retrieve some, that sort of thing, but it's a helpful resource. Okay, was there anything else?
Okay, guess not. I think we can go ahead and get wrapped up. Jason, thank you so much for the awesome session. Hopefully, everybody got something new to learn today. So like we mentioned, at the beginning of the session, we have the next one coming up from Greg, who's also the co-author with Jason. So definitely look forward to that session. We will confirm the date and time, and please check out the social post on that shortly. We will upload the recording for this as well. Hopefully by tomorrow, you should be able to see that in the YouTube playlist that we have hosted the other two recordings as well, right? With that, thank you very much, Jason, and thank you all for joining in. We wish you a wonderful rest of the day, evening. Thank you.
Thanks, everyone.